In the recent years, the trend of building applications in the microservices approach arrives. And building application in such architecture has a lot of good points, but also has some drawbacks. And we need to be able to implement microservices in a proper way to alleviate those drawbacks. And in this section, we will focus on explaining how good microservices should look like and what characteristics it should has. So we'll be looking at a 12-factor app manifesto that explains everything related to microservices and how they should be created. We will learn about every factor and we will learn how to apply those rules to our microservice. And in this video I will be explaining factor of 1, 2, 3, 4, 5 and 6. So let's go into those factors. So we'll be looking at the codebase of microservices. How does it should look like? We'll be creating a config of microservices and we'll be looking at the build process for microservices. So continuous integration for microservices. So first rule is a codebase. So our microservice should have one codebase tracked in the revision control and it could have many deploys. 12-factor application, so our ideal microservice, is always tracked in a version control systems such as Git, Mercurial or Subversion. Multiple applications sharing the same code is a violation of 12-factor. So we cannot have one repository and couple applications that use the same repository. There is only one codebase per application, but there will be many deploys of the app. A deploy is a running instance of the application. This is typically a production site and one on more staging site. Additionally, every developer has a copy of the app running in the local development environment, each of which also qualifies as a deploy. So this is our microservice. We have a codebase and deploys. So one codebase could be deployed on production, staging, test, on developer 1 machine, developer 2 machine. Second factor is dependencies. So we need to explicitly declare and isolate dependencies. And ideal 12-factor application never relies on implicit existence of a system-wide packages. It declares all dependencies completely and exactly via a dependency declaration manifest. Like for example in Maven we have pom.xml, in Gradle we have Gradle build, in SBT we have build SBT file and so on. Furthermore, that application uses a dependency isolation tool during execution to ensure that no implicit dependencies leak in from the surrounding system. And benefit of explicit dependency declaration is that it simplifies setup for developers that needs to develop the new app. The new developer can check out the codebase to its local development machine and it only requires the language runtime and dependency manager installed as a prerequisite. All dependencies will be downloaded by the dependency manager. Third factor is config. So we need to store config in the environment. And application config is everything that is likely to vary between deploys, as we remember those staging, production, developer environments and so on. And this includes credentials, resource handlers to database and other things. And the 12-factor app stores config in environment variables. And variables are easy to change between deploys without changing any code. Unlike config files, there is little chance of them being checked into the code repo accidentally. And unlike custom config files or other config mechanisms, such as Java properties, they are language and system agnostics. Fourth rule of microservices is baking services. So we need to treat baking services as an attached resource. A baking service is any service that app consumes over the network as a part of its normal operation. Examples of those baking services are MySQL or CouchDB, messaging queue systems like RabbitMQ or Beanstalk or Kafka, SMTP services, and caching services, so for example Memcache. Each distinct backend services is a resource. For example, MySQL database is a resource. 12-factor app treats these databases as attached resources. That indicates they lose coupling to the deploy they are attached to. So we have a production deploy and some attached resources: Twitter, Amazon, S3, and other, MySQL and other things. Fifth rule of 12-factor app is build, release, run cycle. Codebase is transformed into deploy through 3 stages. First stage is the build stage, and it transforms and converts code from repo into executable bundle known as build. The release stage takes the build produced by the build stage and combines it with the deploy current config. The resulting release contains both the build and the config and is ready for immediate execution in the execution environment. Last stage, and this is our runtime stage. It runs the application in the execution environment by launching some set of the application processes against a selected release. So we have a code, we have build, and package phase, which assembles build and config and create a release. A release could be executed into target environment. And sixth rule of our 12-factor app is processes. We need to execute our app as a one or more stateless processes. And 12-factor app processes are stateless and share nothing. Any data that needs to be persisted must be stored in a stateful baking service, and this is typically a database. The memory space or file system of the process can be used as a brief single transaction cache. For example, downloading a large file, operating on it, and storing the results on the operation in the database. The 12-factor app never assumes that anything cached in memory or on disk will be available on a future request or job. With many processes of each type running, chances are high that a future request will be served by a different process.